Hello, 171 class. This is your notes for 3.3 part 2, the change of base property. So we have a logarithm with a certain base, b, and what we're trying to do is change the base to another base. And this is the procedure that we're going to do to use it. Now I'm going to show you, again, like we've been showing in the first part of this section, where this property comes from. And once again, it comes from the relationship between logarithms and exponentials. So again, this is s equals log base b of m. This is the exponential form of that. And what I'm going to do here is I'm going to take the log of both sides. And I'm actually going to take the log base a of both sides. And this should be fine, right? Because if two things are equal, b to the s equals b to the s equals m, then the output of logarithms with those equal inputs should be equal. Okay, meaning since b to the s equals m, then the log of b to the s equals the log of m, as long as the bases are the same. And then what I'm going to do is I'm going to take this left-hand side and do the power rule, which allows me to bring that down. And I have s times the log base a of b equals the log base a of m. Alright, and then to finish it up, I'm going to divide both sides by the log base b of a. I'm going to isolate s. So we're right back to s equals the log base a of m. Okay, if I divide both sides by b, this is going to be on the top over here. So log base a of m over the log base a of b. And then finally we're going to switch s back with the log base b of m. So this is s. Now that becomes the log base b of m. And it's equal to this. Okay, and so there's where that property comes from. We are allowed to change the base from b to any other base. That's what the a represents. And the way we do it is we take the log of the original input and divide by the log of the original base. And that new log is the base that we've changed it to. And of course, we're going to change these things to common logs and the natural logs because they're the ones on our calculator. And that lets us evaluate them because of these two being on our calculator. So for instance, the log base 7 of 11. Alright, according to this, that's 7, that's 11. This is the log of the original input, 11, divided by the log of the original base, which was 7. Alright, and then that's the same thing as if I switched it to natural log. The natural log of 11 divided by the natural log of 7. So the change of base property allows us to get a new base based on an older base, a different base. Alright, and just so you can see here, I got the log of 11 divided by the log of 7. Alright, and then there's that number. Remember, what is this number? It's what I need to raise 7 to get 11. So 7 raised to the answer, 7 raised to this power equals 11. Okay, and also again we'll work with natural log. Alright, same number. So it doesn't matter which log base you change it to, as long as you use the same one for top and bottom. Okay, you can't use log here and ln here, ln here and log here. It's got to be the same top and bottom. Alright, use common logs to value the log base 5 of 140. Alright, common logs are base 10, so that would be the log of the original input divided by the log of the original base. So log 140 divided by the log of 5. And do make sure you close those parentheses. So 3.07 roughly. And again, what is that? That's what I need to raise 5 to get 140. So if I raise 5 to the 3.07 power, now I'm approximating, I rounded, I get really close to 140. You need all the decimal places, or you actually need this, the whole entire thing, to be exact. But if you round it, you'll get something really close. Alright, use common logs to evaluate that. Let's change it to natural logs. Alright, so log base 7 2506, that would be the natural log of 2506, the natural log of the original input divided by the natural log of the original base. So there's our number. Okay, and again, if I raise 7 to that power, I get 2506. Alright, so it does work, and it does allow us to evaluate these logarithms we haven't been able to before, or approximate them anyway. Alright, now remember, we talked about it in 3.2. I said that we'll eventually be able to graph these things with a calculator. Well, we needed the change of base property to do it because we only had common logs and natural logs. So we're going to use, as you see here, I use the common log to graph the log base 2 of x. So the common log of the original input divided by the common log of the original base is the log base 2 of x. So we use the change of base property to be able to graph. Okay, and this is just showing you that that point that we said would be on there because of the reciprocal 2, 4 means 4, 2 is on the log base 2, and then we see right here 4, 2 is on that. Just showing you that that point is on there. That actually is the graph of the log base 2 of x. Okay, so we can do any log base, and we don't have to use log, we can use natural log. Okay, I could have done natural log of x divided by the natural log of 2, and that also would be log base 2 of x. See the same exact graph. Alright, there's that same point. So you could use either one, ln, log, there's the same thing. Change it to one of those two bases though, when you use the change of base property.